Okay, till now we see the first step is calculate the range ratio and speed steps. Next step, that is step number 2, calculated the number of stages and number of shafts. Third, structural formula and structural diagram. After that, step number 5, that is optimum structural diagram. Now next is step number 6. Step number 6, that is ray diagram. Okay, the ray diagram corresponding to the optimum structure diagram. The ray diagram is corresponding to optimum structure diagram. Now the structure formula is Z is equal to 2 1 3 2 and 2 6. Now we'll draw the optimum structural diagram. So same, to draw the ray diagram we need ray diagram, and this is your ray diagram and speed chart. Now again same, for the ray diagram we need the number of shafts. So here 1 2 3 4. These are the your shaft S1, S2, S3 and S4. So next is your speed, that is so there is one more shaft in a ray diagram. This is your ray diagram and speed chart. So these are the your this is your Z's, that is N1, N2, N3, N4, N5, N6, N7, N8, N9, N10, N11 and N12. Write down all the speeds. So our N1 is, see here, okay, you can take this value or you can take the values from PSG data books. You can take these PSG values or you can take the value from calculator. It's your choice. So N1 is 20 rpm, N2 is 28.25, next N3 is 39.9, 50.36, N5 is 79.62, N6 is 112.48, N7 is 158.86, N8 is 224.4, N9 is 316.9, N10 is 447.74 and 632.45 and last is 894. These are your speeds. Now see, this is your S1, S2, S3 and S4. In a ray diagram there is a one more shaft. This shaft is motor shaft. This is motor shaft. Okay, might be some problem, they will give the motor speed. Now consider in this case motor speed is around 1000 rpm. Okay, in the problem motor speed is not given. In some problem they will give a motor speed, at that time you have to take the motor speed. So 894, so 1000 will be above this speed, so we will take the speed, motor speed. Now your ray diagram is nothing but your optimum structure diagram, but this will be at your optimum structure diagram, but this will be at only outer positions, means at your outer nodes. See, this is your optimum structure diagram. So write down the formula here, that is 2 1 3 2 and 2 6. This is your structure formula. So draw this outer line only. Okay, see here, this is your outer line, that is first is 6.5. 6.5 is here, from 6.5 node is 7, so here after that this is at 1 is here, last 9 8 which are separated by distance 6 1 2 3, so this is n3 which are separated by distance 1 2 3. So means let's see how to draw. So your minimum speed is n90. So see here, from there will be a two lines which are separated by distance 6. So 1 2 3. So first line will be 1 2 3 4 5 6, and the middle one will be at the center. So this is your ray diagram. And at the last you have to connect the rpm of the motor. So from this point there will be a two lines, so these are the your two lines. From this there will be a three lines which are separated by two distance, and from here there will be a two lines which are separated by distance 6, that is 1 2 3 4 5 6 here. So this is your optimum structure diagram. Just you have to draw the outer lines of your optimum structure diagram. 1 2 3. This is your ray diagram. Now next step. So we draw the ray diagram. This is your ray diagram. Now next is you have to calculate the speed of this rpm, ni. See here is a ni, that is input speed of your gearbox. So ni, that is input speed of gearbox. So we know the formula, input speed of the gearbox. That is we saw during the theory, that is log ni is equal to log n plus log phi upon 2. So this is the your log n. Log n means the speed corresponding to the nearest one, that is either you can select this n6 or n7. So in this case n, this become log ni is equal to log n6 plus log 5 raised to 2. Now log n6 is our speed, n6 is 11 2.48, 112.48 plus log 5. 5 is your step 1, that is 1.4125 divided by 2. So you will get Ni. Ni is 133.68 rpm. This is your input speed of the gearbox. This Ni is of speed. Ni is 133.68. This is your input speed of the gearbox. Now next, okay, that is next step is we just draw the ray diagram. Now next is step number 7. Step number 7, that is gearing diagram. Gearing diagram. For the gearing diagram, just make a table again. That is, this is your first shaft, second shaft, third shaft, fourth shaft. There will be a 4 shaft. So 4 shaft, and there will be a casing, outer casing of the gearbox. So this is your first stage gearbox, this is your second stage, and this is your third stage. Now see here, this is the input speed coming from the motors, and I from the motor, and here will be the output on the shaft. There will be a spindle, lathe machine spindle, lathe machine spindle. Now we know the structural formula, that is optimum structural formula, that is 2 optimum structural formula, that is 2132 and 26. This is your optimum structural diagram. Now the stage 1, this is your stage 1, stage 2 and stage 3. It is stage 1, this is stage 2 and this is stage 3. So this is stage 1, stage 2 and stage 3, and number of pair of gear. Now see, on the first stage, this 2 indicate the number of pairs of gear 2, here the 3 number of pair of gear, and here number of pair of gear 2. So to draw the structural diagram, to draw the structural diagram. So in the first stage there will be a two gears. Two gears. So this will connect to here and here, these two gears. Okay, this will connect to this, and this will, after sliding, will get engaged with these two gears. Now in second stage there are four gears, 1, 2 and 3. Similarly the pairs are 1, 2, 3. These are the first pair, second pair. This is third, fourth, fifth. Now on the last stage there are two gears. So this is 1 which will engage with this, and second is this. These are the 6 and 7. So total gears will be 7 pairs, means 14 gear, that is pinion and gear. Like this there are 7 pairs, so individually 14 gears. This is your gearing diagram. Now next we will see the next step. This is step number 7, gearing diagram. Now we will see the step number 8. Next is step number 8. Step number 8, that is number of teeth on gears. Number of teeth on the gears. For that we need a gearing diagram and ray diagram. Now we know the basic gear train equation, that is, see, between these two gears, that is gear 1 and gear 2, the center distance is same. That is, see how I will write the center distance formula. So first is first stage, center distance between the shaft, that is, first there will be a input gear, output gear. So Z is, now we will consider the Z I, number of teeth on input gear, and ZO is number of teeth on output gear. So in stage there are two gears, gear 1 and gear 2. For that is ZI1 plus ZO1, that is input gear of first gear and output gear, is equal to, that is ZI2 plus ZO2. Got the center distance formula? Similarly we know the another, this is a first equation, important equation, first equation. Now similarly we know the speed and number of teeth relation, that is ZI1 upon ZO1 is equal to output of first upon input of first. These are the NO is nothing but speed of output gear, and NI is speed of input gear, and 1 and 2 are the number of corresponding to the gear number. So this is the another formula. From using these two formulae we will get the number of teeth. Now let's take the stage 1. Stage 1, in the stage 1, so that is Zi1 plus Z01 is equal to Zi2 plus Z02, that is center distance formula. And the next relation is Zi1 upon Z01 is equal to speed of output 1 upon speed of input 1. Similarly, Zi2 upon Zi02 is equal to NO2 upon NI2, that is number of teeth on input of second gear upon number of teeth on output of second gear. This is the speed of the output of second gear, speed of input of second gear. So we need a structural formula for this. So take the, we know the output speed and output input speed. Now see here, that is, consider the first gear. This is your first gear, N1, first gear. This is your first gear, this is second gear, or you can consider this, this is your, you can consider this is your first gear. Just a minute, let me change the marker. This is your first gear, this is your second gear, this is your third gear, fourth gear, fifth gear, sixth gear and seventh gear. These are the seventh gear. So first gear, see the input speed of the first gear, NI1 will be, that is, this is the input speed of the your gearbox. So input speed, we already calculate the input speed. Input speed is this, Ni is 133.68 rpm, and output speed of this gear is NO1 is 1 NO1, see here, that is N7, 158.86 rpm. So these are the input speed and output speed. Similarly for gear 2, NI2 is same, 113.68 rpm, and NO2 will be 112.48 rpm. Now in the speed formula we will get Zi1 and Zi2 relation, that is from the Zi1, this formula, Zi1 upon Z01 will be NO1, that is 158.86 upon Ni, that is 133.68. So Zi1 will be 1.883 Z01. Similarly for second gear, Zi2 upon Z02 will be speed, see, NO2, that is 112.48 upon Ni2 is 133.68. So this can be Zi2 will be your 0.8414 ZO2. So we know this two relation. Put this two relation in distance formula, that is Zi1 plus ZO1 is equal to Zi2 upon ZO2. Now Zi is 1.883 ZO1 plus ZO1 is equal to 0.8414 plus ZO2. So that is 2. This is 183, 2.183. This is 2.183, 1.1883 ZO1. So this become 2.11183 ZO1 will be 1.8414 ZO2. So here is a one. See, see the multiplication factor for ZO1 and ZO2. Whichever has a maximum multiplication factor, that will consider the number of teeth corresponding to that gear, 18 or 20. So we will consider the 18 number of teeth. So Z1. So in this case 2.1183 is greater than 1.1814. So we will consider Z01 is 18. So ZO2 will get ZO2 is 22 around. From this we'll back calculation, we'll get Zi1 will be 22 by putting in this formula. Here put the ZO1 and ZO2. Zi2 will get ZiO2 is 19. These are the number of teeth for the pair 1. Similarly, do the calculation for second stage, that is stage number 2, stage 2. So here there are 3 gears. So center distance between 3 gears are equal 3, 4, 5. So Zi3 plus ZO3 is equal to Zi4 plus ZO4 plus Z is equal to, this is equal to Zi5 plus ZO5. Means there are 3 gears. The center distance between each gear is same. These are the center distances same between the two shafts. So again the write down the speeds corresponding to each gears, that is number of teeth, that is number of teeth and speeds of each gear. So Zi3, ZO3. So this is the speed. The speed will get from the speed chart. Speed chart is Zi3 is, that is 112. Speed is 112.48, and this is corresponding to, and ZO3 output is 224. Similarly Zi4, ZO4, that is speed is same. So see here 112.48 and 112.48, and Zi5 upon ZO5. The speed is 5th gear. The input speed is 112.48 and output speed is around 50.36. So similarly find out the, that is ZI3, ZO3, ZI4, ZO5, this is 4, 5, ZO5. Find out the number of teeth by this two formulae, that is ZI3 upon ZO3 is equal to NO3 upon NI3. These are the speeds. Similarly ZI4 upon ZO4 is equal to ZO3 NO5 upon NI. These are the 4, NI4. ZI5 upon ZO5 is equal to NO5 upon N5I. Similarly find out the for third stage. Now we'll get the Z3I is 36, ZO is 18 teeth, ZI4 is 27 teeth, ZO5 is 36, that is 18 teeth and 36 teeth. These are the stage number 3. Now next is a stage number 5. Similarly calculate for the stage number 3, that is there are two gears, that is ZI6 plus ZO6 is equal to ZI7 plus ZO7 and corresponding speeds. So in the last we'll get the that is the ZI is speed, that is number of teeth and speed corresponding to the each gear. So number of teeth ZI6, the input speed is 50.36, ZO6 output speed will be 112.48. see here, just take the values from this. Similarly ZI7 input speed is, that is 50.36 and output speed ZIO will be 20. This is 7th gear. So number of teeth, calculate the values. These are the values, that is ZI6, ZO6, ZI7, ZIO7. So ZI6 is 56 number of teeth. Next ZO6O is 18, ZCI 21 and ZCO is 53. These are the number of teeths. Okay, this is your last step. So, okay, this is your last step. First we calculate the range ratio, speed ratio, calculate the number of stage and number of shaft, structural formula, structural diagram, optimum structural diagram, ray diagram, gearing diagram, and number of teeth on each gear. So this is the end of your problem.